This is a project presentation for COVID-19 X-ray classification, which is done in a group jointly by Mohammad Sabir Hussain, Mohammad Jain Memon, Mrityunjay Kumar, and Salil Sarma for Georgia Tech Big Data for Health Analytics project. Uh, Broadly, we'll be taking you through following topics: our motivation for this project, followed by research and survey that we have done uh, for similar projects and similar work for COVID-19, different data sources and the pre-processing that we have done on these data. Finally, approach and implementation of our project along with the experiments that we have done with different models to select the best model, and environment and the Git repository, finally with results and conclusion. Uh, COVID-19 is a very contagious disease which is very well proven, and at present there are not many instantaneous and error-free mechanism available to uh, to test a person. At present, the tests that's available are slow or expensive or inaccurate at times. So it is very important to diagnose an infected person early so that the spread can be curbed. Uh, Other methods like CT scan needs a trained radiologist to diagnose a person with CT scan. Similarly, the saliva swab, and blood test also takes longer time. Uh, Chest X-ray method, it is safe, faster, and much cheaper compared to other alternatives, and it can predict accurately for a mild or severe case of COVID-19. In a short span of time, there are many papers that are published by different authors uh, for the similar work of detecting COVID-19 with chest X-ray uh, method. And the methods that they have used are VG19, COVIDNet, ResNet, or ResNet Plus, DenseNet, and these methods are they have also published the results and effectiveness of these methods. So our team has gone extensively reading these papers and doing our analysis to select few model which seems to work well on detecting COVID, and we have taken those models and implemented to see that how does it behave on the COVID data that we have, the data set that we have. And we have implemented ResNet 50, VG16, also a deep CNN model with on our implementation of different layers, and finally COVIDNet. We have chosen pre-trained model of COVIDNet for this project due to since we got the best result from COVIDNet pre-trained model. We have merged different data sources. The complete list of data sources are present in our paper. There are a total of more than 5,000 chest images we have used for training this model, which includes 1,500 normal patient, 1,400 pneumonia patient, and 617 COVID patients. Out of these data set, we also have created a validation set, which is a random image of 100 from our data set. Uh, in part of pre-processing, we merge different data sources, images, depending on the classification. We have created the metadata. Also, we have scaled the images depending on scaled and resized the images depending on the labels and the image source. We few of the images we also had to convert to grayscale. We have used Spark tool to do this pre-processing of images. Uh, our team member Mrityunjay will take you through the rest of the slide in this presentation.
Yeah. So in this slide, I'll be telling about the approach implementation and the various experiments we have done with different models. We have used transfer learning method for COVID net model. Detecting COVID with chest X-ray is a challenging task, and we did a lot of experimentation to conclude this model. It's a deep CNN model, and we tried with that, and it was overfitting with training data and did not provide us a good accuracy. Then we tried with pre-trained model, which was trained with the huge data set. At present, the huge data set are not available for COVID, so that's why we had a limited data set available to us. Using that, we selected, because the data set was not huge, we selected COVIDNet as our model for this experiment. COVIDNet model makes use of projection expansion, projection extension design pattern for input image. In this implementation, the model is evaluated using model as a whole with data and then using only meta graph for the model. The model was pre-trained with ImageNet dataset and then trained on COVID dataset using Adam Optimizer, using a learning rate policy where the learning rate decreases when learning stagnates for the period of time. In this slide, we can see the various layer of neural network, and it explains how it is connected and how one layer is back propagation and forward propagation of data is happening. So for the environment, we have used Python, and in that we have used TensorFlow library and Torch also. And Spark is also Spark is used for image processing, and this is one of the big data tool which we have used. Data processing was done using our local laptop, and also Google Colab was used, and this was sufficient for us to get the training done. It was slow, but it did provide us the result. And the GitHub repo directory is also listed here, where all the files have been shown. So experiment result was good. The model yielded good sensitivity and PPV with both training and test data. The following confusion matrix from epoch 1, 2, 3 shows good improvement with epoch 3, where the COVID case is classified correctly 100% time with test data. Conclusion. So in the end, our final model is accurate and provide good sensitivity to input data. Lack of enough creditable training X-ray images for COVID is still a challenge, and it need to be solved. This project was a challenging one. At the same time, satisfying experiment and gave us opportunity to learn, implement few deep learning algorithms, and analyze their effectiveness in detecting COVID. Machine learning can be used effectively and rapidly in early detection of COVID. Gives a good given a good trained model. Since machine learning model does not require domain expert to detect COVID, this method can be used extensively at the places like airport, bus stop, train station, or any public spot. So in all, we were able to conclude our project, and we achieved the target result. So, and with this, I'll add the demo part of it, which is done by Mohammed Jain.